So guys, let's start from here. So today you will find here, as mentioned there, it's from physics and it is dealing with the mathematical physics. So today we are going to solve a question about the mathematical physics which was asked in JEST. JEST is actually the entrance which is conducted at the national level. It's an NET, that's National Eligibility Test, which enables you to get admission if you qualify this very exam. So you will get admission into the top. If you gain a top ranking, then you can get even admission in the ICTS, that is in the Bangalore. So it is very much precious and very much, I can say, very much important exam as far as physics research is concerned. So let's take the example which was asked in the exam of JEST 2012, which is here. So as you might be able to see here, the question is saying that what is the value of the integral. The integral is definite integral taken from 0 to infinity ln of x divided by x square plus 1 to the power 2 with respect to x. Its integration we have to calculate, and here are some options given there, so we have to calculate which one is the answer. So for that, it is a differential, it's an integral, although it is an indefinite integral. So it can be solved through which you might be very much well known about, the Cauchy's integral. So from the diagram we are able to see here that there is, if you look into the question, the integral given here excuse me. So here in the integral you will find that the x variable in the denominator. So here you might be able to see here x square plus 1. So if we calculate, first of all, the condition for which you have to be very much cautious about to find the integrals is that you have to find whether the denominator may approach to 0. It may become the indefinite form, it may take the indeterminate form rather. So that is 0 by 0 or any number divided by 0, so which is not defined. In this case, what will be the value of x? So for that, we will be doing x square plus 1 equal to 0. So for that, x square plus 1 is equal to 0. That means x square is equal to minus 1. So that means x is equal to under root, that is iota. That's I. So for this, we have it's called as the pole. So here we can say that the integral does not exist on the value of x equal to 0. So we have to exclude that. For that, we represented this by this diagram, which is here. So here you will find that it does not exist, and similar case, but we have to form a contour which is around this, this you might be able to see there. This is the 0 where the integral does not exist. So here we are enveloping this by the contour, but this envelope is so much minute and so much small that it touches nearly we can say it is nearly in the neighborhood of this very eye. So we will form a contour which will be of the following paths, like following this path which is represented by R, then again from this path which is represented by A, then smaller path which is R, because it is just like a circle with a minute and tiny point missing, and it is near about a circle with only one point missing. So we can say that another contour path is B. So this is the complete contour here, which you can see. So trying to solve it by the method of residue theorem, so we can solve it here. You might be able to see this integral. After that, this is the second order differential equation using the formula given by Cauchy integral theorem. So you can use that very theorem in here. After solving a bit, you will find this very thing. So the residue will be equal to this very thing, and you know that at a loss by the Cauchy's theorem, that integral is equal to 2 pi r times something times the summation of the residues, and the residue here is equal to this, and this is included here. Residue is included here. So on solving, you will get an idea about this very integral here. So on solving, when you'll get complete solution about it, so you'll be able to find out here that here you will find on the path A like this differentiation, on path B and on internal circle, which is the smaller one, which I showed you earlier that it is smaller circle, and then the outer circle. These are totally opposite to each other. It's cancelling, A and B are cancelling, but it is here we are at Z equal to this and V equal to this. On solving this very integral here, you can get pi I square then is equal to this very integral. So in short, when you're calculating the integral of this very huge quantity which is given in the question, so you'll find able the question, its answer is given as here. So that was all about the demo of this, how to solve a question from JES 2012 from mathematical physics. Thank you. Have a nice day. Have a nice journey. See you around in the next.